Hi everyone, this is Sharan here. Welcome to my channel. Today in this video, we are going to see the concepts behind the logistic regression. So first we are going to see what are all the various scenarios where an logistic regression can be used, what are all the different predictive problems where this can be applied, and why a linear regression cannot be used for a problem which needs to be solved using logistic regression. So there is a reason why we have a logistic regression in place. And we are going to see what is an sigmoid function. So what is the equation for the sigmoid function and what it signifies, what is the reasoning behind that particular function that we use in case of logistic regression, how it helps in making the prediction better. And then how do we identify the weights? There are various methods to estimate the weight, but in this video we are going to see the Loglikelihood function. So what is this function and how it helps in identifying the weight? And finally, after making the prediction, how can we measure the accuracy of the model? So we are going to see confusion metrics, what it is, how it can be useful in measuring the accuracy of the model. Okay, so now before getting into the concepts, if you are looking forward to learn data science, please consider subscribing to my channel. I publish various videos related to data science, both tutorial as well as related to various topics that could be helpful for your data science career. So now getting started into the topic. So what is logistic regression? So logistic regression is used for a problem where we want to make a prediction which is binary. So the output that we are going to predict is going to be binary, 0 or 1. So a typical example would be whether a loan has been sanctioned to a particular customer or not. So 0 means not sanctioned, 1 is sanctioned. Whether an email is spam or not. So 0 or 1. Whether a transaction, like in a financial institution, is a fraudulent transaction or not. So again 0 or 1. So in all these scenarios, the dependent variable, the variable that we are going to predict, will be 0 or 1 in case of logistic regression. So it is a classification problem, but it is binary, which means that it can take only two values, 0 or 1. It can have only one of the two categories. And the input that we are going to use, the independent variables, can be anything, like it can be continuous, it can be categorical, it can be anything, very similar to what can happen in a linear regression problem. So this is what logistic regression is. It's very similar to a linear regression. The only difference is the output that we are going to predict can have only two values, either 1 or 0, or it can have two distinctive categories. So that's what is logistic regression is. So now the first one is, why can't we make use of linear regression for logistic regression problem? Let's say we want to identify whether an email is spam or not, or we want to identify whether a transaction is fraudulent transaction or not. Why can't we use linear regression for that kind of problem? Okay, so let's see with an example here in this whiteboard. So here, as you see, in case of logistic regression, the y-axis, which is the column that we are going to predict, will be 0 or 1. So you can see various points in this data plot. So it's either here in 0 or it is in 1. Whereas the x-axis is the independent variable. So here in this case, it is a simple example. So where we consider there is only one independent variable. So let's take an example such as credit rating. And this is the credit rating. And this represents whether a loan was sanctioned or not. So 0 means not sanctioned, 1 means sanctioned. And this is the credit score of the particular customer. So now we can see as the credit score increases, after a certain point, the chances of getting a loan is higher because it becomes 1. So when the credit score is not so much, the loan is not getting sanctioned. So in this particular example, let's say we are going to use linear regression to make the prediction. So if you have not seen the linear regression concepts, go back to my video on day number 51, where I have explained the linear regression concepts, how it works. So in a linear regression, so assuming you know how linear regression works, so what happens is when you solve using the ordinary least square solver method, the regression line passes through mean of the x as well as the y-axis. So in this case, the value that we are going to predict can have only 0 or 1. So the mean would be 0.5. So this needs to pass through this particular point here. And here in this case, so we can see the values ranges from this here to here, and the mean should fall somewhere here. So both the points would meet here, and the regression line needs to pass through this particular point. And if we take this particular example, then what we can do is we can identify this has the decision boundary. So whenever the x value crosses this particular point, goes to the right hand side, so then the prediction, we need to make the prediction as 1. That means that loan is sanctioned. So when the x-axis value is before this particular line here, so then we say that loan will not be sanctioned. So based on the training data set that we have. So this is a normal example, and here in this case of in this example, we can clearly see that linear regression works perfectly fine. But then why we can't use linear regression? So we will take up another example. So let's take this particular example here. So as you see here in this example, there is one outlier that you can see on the extreme right hand side. So here in this case, just one outlier is enough to make it very bad for linear regression problem. So because of this outlier, what happens is the mean value for x moves towards the right. So from here, it now moved to this particular point. So now if we use this as a reference point and predict all the values that are falling right hand side to this particular value, as like the loan will be sanctioned for those values. So then what happens is, for the majority of the values, so for these values where the loan has been sanctioned, will be predicted as 0, which means that they will be predicted incorrectly. Why? Because of this particular outlier. Because of just one outlier, the linear regression cannot be used for this kind of situation. So in a real life scenario, there will be a lot of outliers. So that's the reason why we can't use linear regression in order to make a prediction which is binary in nature. So what happens in case of logistic regression? So in case of logistic regression, what happens is we make use of a function called as a sigmoid function. The equation for the sigmoid function is 1 by 1 plus e power minus f of x or t, where this t, this can be represented as a linear function, like which is very similar. This equation, that you should be aware of this equation which we have covered in linear regression, which is beta 0 plus beta 1 x1 plus beta 2 x2, like as many as independent variables as we have, where beta 0 is the constant. So now let's substitute various values for t and then see what happens to this. In this equation, since we divide 1 by and then we are adding value e power minus t to 1. So then here what happens is the value of the denominator is always going to be greater than the numerator, because we are having the same value here and then we are adding some value addition to it. So now what happens is this sigmoid, this function cannot be greater than 1. So it needs to be lesser than 1. And if we substitute various values, for example, if you see for t, if you substitute value of minus 10, so then the value of e power minus 10 becomes almost very closer to 0. So it will be 0.000001. And as you increase the value, like e power minus 100, it becomes very closer to 1. So then what happens in this equation is, in this equation, the value of sigmoid will be very close to 1. It won't be exactly 1 because we are adding 1 plus and small value to it. So the value will be very close to 1. On the other end, let's say we have e power, like we have a positive number here, let's say e power 10. So then the value becomes very high. So if you see here, e power 10 is 22,026. So now if you substitute that value here, then the value of sigma will become very closer to 0. So in this equation, typically what happens is, so this curve represent the sigmoid function. So it will be mostly closer to 0 or closer to 1, and it briefly goes through this particular point here. So majority of the cases it will be either here or here. So that's the sigmoid function. So that is the function that is used in order to make the prediction. So now how do we identify the weights in case of an logistic regression? So one of the methods which can be used to identify the weights is called as Loglikelihood function. So which can be represented by this particular equation here. So where yi log of probability of the predicted value p of xi is the point that falls on this red line. So this red line is what the probability prediction that we are making. So as you see here, the dot as well as plus here both represents the actual value. The red line is the is the probability value that we are predicting, and these two are the actual values, which is represented by yi, and this is the linear function which is represented here. So now we want only 1 and 2, like we want yi, like what is the actual value and what is the probability or what is the value that we are predicting. So if we take an example, let's say the actual output value is 1 and we are going to predict 1 as well. So then what happens is, so here this part of the equation becomes 0. So the log likelihood function that will be considered for this particular case when the value of y is 1 is only this part of the equation, because the second part of the equation becomes 0. So this part yi is 1. We know that when the probability value is closer to 1, the value that we are going to predict is correct, is almost closer to 1. So then what happens is this value becomes closer to 1. So if it is 1, log of 1 is 0. So then this value also becomes 0, which is minimum. Whereas on the other hand, if the value that we are going to predict here is not equal to 1, let's say it is on the other hand far from 1, like maybe closer to 0. So then log of an value which is closer to 0 will be a negative number. So the closer it is to 0, then the larger the negative number it is. So then what happens is this function will be penalized heavily. If it is very far away from 1, so then it is penalized heavily. So then what it becomes is, it becomes a huge negative value. Similarly, let's say we want to make a prediction and then the actual value is 0. So if the actual value is 0, then this part of the equation becomes 0. So then this would be the sigmoid function here. So 1 minus 0 will be 1. So log of, if we are able to predict a probability which is closer to 0, so then again it will become log of 1 and then it will become 0. If on the other hand the probability is like it's far from 0, so then let's say it is maybe 0.99. So then what happens is 1 minus 0.99 would become log of 0.01. So then this will become a negative value, like the closer it is towards 0, then it will become a larger negative value. So if it is a larger negative value, then it will be heavily penalized. And hence, so this log likelihood function, if we try to maximize this log likelihood function, so then we would be able to identify the weights for this particular equation. So that is the purpose of log likelihood function. There are various functions that can be used in order to predict, in order to identify the weights in case of logistic regression. So this is just one of the method that is commonly used. So now let's assume we have made the prediction. So now how do we measure the accuracy of the model? So there are various methods again. So one of the methods that is commonly used is an confusion matrix. So as you see here, so this is an confusion matrix. So here the actual value can be 0 or 1. Similarly, the predicted value could be 0 or 1. Our purpose should be to maximize these two values, true negatives as well as true positive. We need to ensure that majority of the value that we are going to predict will lie in these two boxes. If that is happening, then it means that we are able to predict as accurately as possible. So these two are false positive and false negative. So the actual value is 1, but we are predicting that value as 0. So then it means that it is false negative. If the actual value is 0 and then we are predicting it as 1, so then it is an false positive. So these two values should be minimized, whereas this diagonal should be maximized. Majority of the values should fall into this particular diagonal. So then the accuracy of the model is really good. So this is a technique that can be used to measure like how good the logistic regression model is working. So that's it about logistic regression. So I hope you would have understood why a linear regression cannot be used in case of logistic regression. The reason is if we have some outliers, so then the linear regression would fail terribly in making the prediction, which is binary in nature. So hence we use logistic regression. So in case of logistic regression, we use sigmoid function. So the value of sigma in sigmoid function will be mostly towards 0 or towards 1, because so these are all the various values. So as you see here, as the value of t increases, it either goes closer to 0 or it becomes extremely high. So if it goes closer to 0, so then the sigmoid function, like the value would be closer to 1. If it is going to be a very big value, so then it is going to move towards 0. So it's most of the cases it will be lying like either closer to 0 or closer to 1. And in order to predict the weights for the equation, we use Loglikelihood function. So where we try to maximize this particular value here, and we use that to identify the weights for the equation, and we measure the accuracy of the model using confusion metrics. So that's one of the techniques that's popularly used. So that's it about the various concepts behind logistic regression. I hope you would have learned something new today. If you have learned something new today, please give a thumbs up and let me know in the comment like how useful it was for you in understanding this particular concept. In the next session, we will see how to implement logistic regression using Python.